This is the third question in the FRQ 4 practice packet. So part A gives us two functions. In the first step of part A, we're going to substitute in 1 for g of x. And so I want the AP reader to understand all of my work. I'm going to write it down first. I'm also looking at the domain here with what I can input in. I know there's no restrictions with what I can input in for x. This value in the x1 position can be positive, negative, or equal to 0. So 1 equals 8 raised to x times 8 raised to 2x over 8 raised to the 5th. When you have the same base, if you're multiplying, you're going to add the exponents. Alright, that gives me 8 raised to the 3x over 8 raised to the 5th. Alright, and at this time, let me just make sure here, we're going to solve and making sure I got that right. At this time, I have 8 raised to, when I'm condensing this, I have the same base I'm dividing. I keep the base the same, and I'm going to subtract the exponents. 3x minus 5. So sorry here. Okay, now I need to eventually solve for x. So how do I do that? I'm going to take log base 8 to the left and log base 8 to the right. As long as I do it to both sides, I can bring everything else down. What does this mean? This means off to the side, it means 8 raised to what value equals 1? Well, the only way to achieve an answer of 1 is if you take 8 and raise it to the 0 power. 8 to the 0 power is 1. So on the left-hand side, I have 0 equals log base 8 of 8 raised to the 3x minus 5. Log base 8 and 8, and I bring down the 3x minus 5 equals 0, adding 5 to both sides. I get 5 equals 3x divided by 3. 5/3 equals x. Don't circle this result. We want the reader to see all of the work that led up to that result and not negate my work. On right now to the second part of A, and so I'm going to take h of x equals 2. I'm going to substitute in here 2 equals log base 4 of x plus log base 4 of 5. As a quick reminder, this value, x must be greater than 0. Let's get started. So I'm going to compress the right-hand side. Right now, it's extended form, and so when I do that, we have the same log base. Addition turns to multiplying, so x times 5. So this is 2 equals log base 4 of 5x. And we're going to write this in exponential form. So it's the base raised to the value on the opposite side of the equal sign equals the value behind. 4 squared is 16. Divide by 5. And now I do need to check this answer. 16 over 5 is greater than 0. This is my final answer. Alright, let's take a look at what we can do here. So I'm going to rewrite this function and have a fraction that involves only sign values. No other trick values at the very end. So I have not worked through this prior, so hold tight with me. What could I do? So I could rewrite sine squared, or excuse me, I could rewrite tangent squared as sine squared over cosine squared, or I could even use the Pythagorean identity. Let's see, which would be secant squared plus 1. Just deciding what I want to do here. I think it's going to be to my advantage to write sine squared over cosine squared. I can always go back and change this. Now, I also know that secant is the same as 1 over cosine. And I want to divide this all by the secant of x. So I have sine squared over cosine squared and cosine squared again. And I'm going to turn division into multiplying, and we're going to take the reciprocal of the second fraction, which is 1 over the cosecant. Now, 1 over the cosecant is the same as sine, so really this equates to just sine, and so I'm going to take that out and simply write the sine of x. So now I have sine squared x times sine of x over cosine to the 4th. Alright, I have, oh goodness sakes here, So let me keep going here. This is what I have right now. So I've rewritten 1 over the cosecant as a sine of x, and so I have sine cubed x over cosine to the 4th. And I know that I need to rewrite this as a power of only sine. So I'm going to rely on what I know, and I know that, oh sorry, let me go back here. I know that I have sine cubed x, and let me go back and write this as 2 groups of sine squared, or cosine squared. So cosine squared x and cosine squared x. Now the reason I'm doing that is I know that the most common Pythagorean identity is sine squared x plus cosine squared x equals 1. And so I could rewrite cosine squared x as 1 minus sine squared x. So in the denominator here, I have sine cubed x, and I should have had the entire time writing j of x here, not to lose sight that I'm literally just rewriting this function in an equivalent form. That's important to know. Okay, so now I'm going to replace this cosine squared x with 1 minus sine squared x, and again, 1 minus sine squared x. Alright, so I have sine cubed x over, now if I FOIL this out, I have 1, does it say a single sign? I gotta go back. Involving powers of sines. Okay, it doesn't say a single sign. Okay, so then I would have 1 minus sine squared x to the 2nd power, because it's 2 groups to that. And this is where I believe I would stop. I do want to make sure that cubed is up top and it's not confused with a 3x. It does not say a single sign. I believe this is not the result rewritten in the form that only has a sign in our final simplified answer. Let's look at the second part of B. We're going to go up to k of x, and we want to rewrite this involving only a cosine of x in the expression. So I have this, and I recognize that the sine of 2x is equivalent to sine of x times the cosine of x. So I'm going to replace this portion with 2 sine of x cosine of x times the sine of x. Alright, so I have 2, and maybe I want to write the cosine first, it doesn't make a difference. And then I have sine squared x. Now, the most common Pythagorean identity is sine squared x plus cosine squared x equals 1, and I can simplify this and rewrite it in the form that cosine squared is equal to 1, sine squared is equal to 1 minus cosine squared. So I have 2 times the cosine of x, and now I'm going to replace sine squared with 1 minus cosine squared x. And now I have the form that involves only cosines, and I believe I could stop at this point.